Everyone, welcome to Abhi online classes. Today I am going to discuss some types of discontinuity in limits and continuity chapter. First we will see first type, removable discontinuity. That is, if limit extends to a f of x exists but it is not equal to f of a. That means limit extends to a f of x is not equal to f of a. We call this as definition 1. Or limit extends to a plus f of x is equal to limit extends to a minus f of x. Right-handed limit must be equal to left-handed limit, but both are not equal to f of a. This is we call it as definition 2. So if limit extends to a f of x is not equal to f of a, or right-handed limit is equal to left-handed limit, but both are not equal to f of a, then we say f has removable discontinuity at a. We see one example. First example, test for the continuity of the function f of x is equal to sin x by x for x is not equal to 0, and this is equal to 0 if x is equal to 0. First we see by definition 1 we solve this problem. Limit extends to a f of x. In this problem a, that is limit point, is 0. Limit extends to 0 f of x. This is equal to limit extends to 0. Here f of x is sin x by x. As we all know, limit extends to 0, sin x by x is equal to 1. Now we will see in the corner, in the margin, for x is equal to 0, we put x is equal to 0 here, f of 0 equal to 0. 1 is not equal to 0. That means 1 is not equal to f of 0. That means limit extends to 0 f of x is not equal to f of 0. Limit extends to a f of x is not equal to f of a according to the definition 1. Then f has removable discontinuity at x is equal to 0. Now we will see one more problem. Test for the continuity of the function f of x is equal to x into e power 1 by x by 1 plus e power 1 by x for x not equal to 0, and f of x is equal to 1 if x is equal to 0. First we take a left-handed limit. That means limit extends to a minus f of x. Limit extends to a. Here the limit point is 0. 0 minus f of x is x into e power 1 by x by 1 plus e power 1 by x. Limit h tends to 0. We replace x by 0 minus h. We replace x by 0 minus h as h tends to 0. Limit h tends to 0. We replace x by 0 minus h e power 1 by 0 minus h by 1 plus e power 1 by 0 minus h. Limit h tends to 0 minus h into e power minus 1 by h by 1 plus e power minus 1 by h. As we all know, e power infinity equal to infinity and e power minus infinity is equal to 0. We should remember these 2 points. As h tends to 0, this is a 1 by 0, that means infinity. E power minus infinity is 0. So minus, we put h 0. E power minus infinity is 0. E power minus 1 by h. h tends to 0. 1 by 0 is infinity. So minus infinity. E power minus infinity is 0 by 1 plus 0. 0 by 1 gives 0. Therefore, left-handed limit, this is limit. Left-handed limit is 0. Now we will see right-handed limit. Limit extends to 0 plus f of x. Limit extends to 0 plus, here f of x is x into e power 1 by x by 1 plus e power 1 by x. Now we replace here x by 0 plus h. 0 plus means we have to replace x by 0 plus h as h tends to 0. limit h tends to 0, 0 plus h. We are replacing x by 0 plus h. E power 1 by 0 plus h. 1 plus e power 1 by 0 plus h. Now this is equal to limit h tends to 0, h into e power 1 by h by 1 plus e power 1 by h. Here we should not directly substitute h is equal to 0 in e power 1 by 0. What we should do, limit h tends to 0, h into e power 1 by h by, we take e power 1 by h as common. Now this is e power minus 1 by h plus 1. So on taking e power 1 by h on both these terms, e power 1 by h into e power minus 1 by h. So on multiplying both of these two, e power 0 we will get. That means 1. So we are writing 1 as e power 1 by h into e power minus 1 by h. On taking common e power 1 by h, we are getting here 1. Now we should cancel these two terms and then we substitute h is equal to 0. E power minus 1 by 0 plus 1. 0 by, previously we have discussed, e power minus infinity is 0. So e power minus infinity is 0. So we got right-handed limit is also 0. So we have observed left-handed limit is 0. Right-handed limit is 0. Next we find out f of 0. Already in the question itself we have x is equal to 0. Put x is equal to 0 in this. F of 0 is equal to 1. Therefore this is equal to 1. What we have observed, left-handed limit is equal to right-handed limit, but both of these two is not equal to f of a. But both are not equal to f of 0. Therefore the conclusion is left-handed limit is equal to right-handed limit, but both are not equal to f of a. F of a means f of 0. Here the limit point is 0. So therefore f has removable discontinuity. F has removable discontinuity. Yet x is equal to 0. So in both the definitions we have seen one example. In the first example we have seen definition 1 and in the second example we have seen definition 2. Hope you understood about removable discontinuity. Now we'll see next type of discontinuity, that is discontinuity of first kind or jump discontinuity. If limit extends to a plus f of x and limit extends to a minus f of x, both exist but they are not equal. That is, right-handed limit is not equal to left-handed limit. Right-handed limit is equal to f of a in this definition. Here left-handed limit is equal to f of a. That means any one must be equal to f of a. But right-handed limit is not equal to left-handed limit. We see one example, then we can understand much more. Consider the function f of x is equal to mod x by x for x is not equal to 0 and f of x is equal to 1 if x is equal to 0. First we take left-hand limit. Limit extends to a minus f of x. Here the limit point a is 0. So therefore we put in place of a 0. Limit extends to 0 minus f of x is mod x by x. So we take the definition of mod x. Mod x is equal to plus x if x is greater than 0. That means 0 plus. Mod x is equal to minus x if x is less than 0. That is x is in the negative neighborhood of 0. So in the negative neighborhood of 0, we write mod x as minus x. Cancel x. Limit of constant is constant. Therefore limit of minus 1 is minus 1. So we got left-handed limit minus 1. Now right-handed limit. Limit extends to a plus f of x. Limit extends to, we replace a by 0, 0 plus mod x by x. F of x here is mod x by x. So for 0 plus, that is in the positive neighborhood of 0, we write mod x as plus x. So we replaced mod x as by plus x. Cancel x. Limit of 1 is 1. Therefore, right-handed limit is plus 1. Obviously, left-handed limit is not equal to right-handed limit. And in the question itself, we have put x is equal to 0 in this. F of 0 equal to 1. We have f of 0 equal to 1. That means this one is equal to this one. That is here right-handed limit is plus 1. Now this is equal to f of 0. Now this is the discontinuity of first kind, or we say jump discontinuity. Therefore, f is discontinuous at x is equal to 0. Discontinuity of first kind, or you can say f has jump discontinuity, or you can say f has jump discontinuity at x is equal to 0. Now we'll see one more problem in discontinuity of first kind. Test the continuity of the function f maps from R to R be such that f of x is equal to e power 1 by x minus e power minus 1 by x by e power 1 by x plus e power minus 1 by x if x is not equal to 0, 1 if x is equal to 0. Very important problem for B.sc students. We'll see. First we take left-handed limit. Limit x tends to 0 minus f of x. Limit x tends to 0 minus f of x here is e power 1 by x minus e power minus 1 by x by e power 1 by x plus e power minus 1 by x. We replace x by 0 minus h as h tends to 0. Limit h tends to 0, e power 1 by 0 minus h, e power minus 1 by 0 minus h, e power 1 by 0 minus h plus e power minus 1 by 0 minus h. Limit h tends to 0. This is e power minus 1 by h minus e power minus into minus plus, or we can cancel minus, plus 1 by h by e power minus 1 by h plus e power 1 by h. As we have discussed earlier, we have seen limit h tends to 0, e power 1 by h gives infinity. E power minus 1 by h gives 0. So now we have to remove e power 1 by h from this problem. So we take common. Limit h tends to 0, e power 1 by h common. So when we take in e power 1 by h as common, this becomes e power minus 1 by h minus 1 by, here also we take e power 1 by h as common. This will become e power minus 2 by h plus 1. Now we cancel e power 1 by h. Now on substituting h is equal to 0, e power minus 2 by 0, that means e power minus infinity minus 1 by e power minus infinity plus 1. E power minus infinity is 0. 0 minus 1 by 0 plus 1. So minus 1 by plus 1 means minus 1. So we got left-handed limit minus 1. Left-handed limit minus 1. So on substituting h is equal to 0, 2 by 0 infinity. So it is e power minus infinity. E power minus infinity is 0. So 0 minus 1 by 0 plus 1. So left-handed limit minus 1. In the same way, we'll solve right-handed limit. Limit x tends to 0 plus f of x. Limit x tends to 0 plus, here f of x in the problem, e power 1 by x minus e power minus 1 by x by e power 1 by x plus e power minus 1 by x. Now we replace x by 0 plus h as h tends to 0. Limit h tends to 0, e power 1 by 0 plus h minus e power minus 1 by 0 plus h by e power 1 by 0 plus h plus e power minus 1 by 0 plus h. Limit h tends to 0, e power 1 by h minus e power minus 1 by h by e power 1 by h plus e power minus 1 by h. In this problem also we have to remove e power 1 by h. So we take e power 1 by h as a common. E power 1 by h common. So 1 minus e power minus 2 by h by e power 1 by h, denominator also common. 1 plus e power minus 2 by h, cancel. So on substituting h is equal to 0, e power minus 2 by 0 means 2 by 0 gives infinity, e power minus infinity. So 1 minus e power minus infinity by 1 plus e power minus infinity. E power minus infinity gives 0. So 1 minus 0 by 1 plus 0. That means 1 by 1. This is equal to 1. So we got right-handed limit 1. So we got left-handed limit is minus 1, right-handed limit is plus 1, and in the problem we have on substituting x is equal to 0, we got f of 0 equal to 1. Therefore, left-handed limit is not equal to right-handed limit. We have observed just now. Left-handed limit is minus 1, right-handed limit is plus 1. Therefore, these two are not equal. But right-handed limit is equal to f of 0. Therefore, f has discontinuity of a first kind at x is equal to 0, or f has a jump discontinuity at x equal to 0. Hope you understood this class. These are very important problems for B.sc students. So, thank you.